Hi, today I'm going to show you how to work out a practical example of Kirchhoff's law using Ohm's law. Don't forget to check out my videos on calculating Ohm's law in a series circuit and also parallel circuits if you're confused. I'm going to show you step by step how to work this equation out. So firstly, we have to look at what we're trying to find. We have our voltage drop, our resistance in R1. We're trying to find the voltage drop against R2 and also the value of R2. R3 we have a voltage drop but not the resistance. We have to work out the current first. So if we have a look here at our Ohm's law formula, and we've got 10 volts of voltage drop divided by the resistance, which is 40 ohms, equals 0.25 amps. Now remember, in a series circuit the current is constant, so we can use that value as our circuit current. What we can do, now that we've got the current, we can find the resistance, because we've got 25 volts and we know the current now, so we can use R equals V divided by I. 25 divided by 0.25 equals 100 ohms of resistance. The next step, what we're going to do is to find the values here. The easiest one to do is the voltage drop, because Kirchhoff's voltage law in a series circuit states that the sum of all voltage drops equals the supply voltage. So we've actually got the supply voltage and we've got two of the voltage drops. So we write the equation: supply voltage is equal to voltage drop 1, voltage drop 2 and voltage drop 3 in this case. So if we have 50 volts equals 10 plus what we don't know plus 25, so we transpose the formula to work it out. So what I like to do is to write the equation backwards. So 10 plus voltage drop 2 plus 25 equals 50. So what we have to do is transpose. So we want to leave this on this side of the equation and transpose everything else to the other side. Now if we start over here, 10 is a positive number. So what we have to do is do the opposite. So if it's plus 10 this side, when we move it over here, it's minus 10. So we minus 10 from both sides of the equation. And then we look at 25. 25 is plus 25 this side, so when we move it over, we have to subtract. So these two cancel each other out, and we've got 50 minus 10 minus 25. That gives us a total of 15 volts. Next we're going to find the last resistance. So now that we've got our voltage across that resistor and we know the current, easy. R equals V divided by I. 15 divided by 0.25 equals 60 ohms of resistance. Okay, so we can actually check to make sure our calculations are correct. If we take the total resistance and the current, we can work out the supply voltage using Ohm's law. So let's have a look. V equals I times R. So the current of 0.25 multiplied by the total resistance, which is 200, equals 50 volts. And that's what we started off with.